We are on our last lesson for the week. We're on section 5.6. So we're going to look in your book on page 125. This is not hard, but it takes a little bit of explanation. So I didn't want you to just read through it. I wanted to talk to you through it. All right, so basically we're going to learn today to add and subtract fractions. You might think, oh, that's going to be simply easy. We just add and subtract, but that's not the case. All right, so it starts out with an example. Say you're planning a party. You spend $9 on 12 plates, $5 on 10 cups, $2 on 50 napkins, and $8 on 45 sets of silverware. How much are you spending altogether per place setting, which would be 1 plate, 1 cup, 1 napkin, and 1 setting of silverware? An easy way to find that out would be to express each division as a fraction and then add them all up. So $9 would be 9 out of 12 because you bought 12 plates at $9 each. So to determine how much each plate costs, you would say 9 divided by 12. Okay? Plus the cups, plus the napkins, plus the silverware. You'd put your fraction down there. And what does that equal? Well, turn the page. Now, say you go to the hardware store, find a piece of wood on sale that's 11/12 feet long. But you only need half a foot for your project. So how much will you have left? Would you be saving money if you bought it instead of buying a different piece that's exactly the length that you need? Or if you ever have made yeast bread, you probably added flour to a mixing bowl a little at a time. Maybe you added half a cup, then a fourth of a cup. How would you figure out the total quantity of flour used? Clearly, you have to add and subtract fractions, but how? Consider adding 4 halves plus 8 fourths. In that case, you could just do the division and it's 4. Because 4 halves equals 4 divided by 2, which is 2. And 8 fourths is 8 divided by 2, which is 2. And you just add those up and you get 4. But there is a way to add fractions fractionally, I guess you might say. While we could add and subtract most everyday fractions by converting them to decimals, but we're going to learn that later on in a couple more chapters. It's essential to know how to add and subtract fractions as fractions. It's a concept that you'll use extensively in algebra to explore the relationships and consistencies in God's creation at an even deeper level. And while you may already know the mechanics, hopefully our exploration will help you see what's really happening when we add and subtract fractions and how it is ultimately possible because of God's faithfulness. All right, let's think it through. We want to find a way to add fractions. So let's take 1/2 and 1/4 for examples. So 1/2 represents 1 divided by 2, which would result in a quantity equivalent to 1 part out of 2 parts. In other words, half of a whole. Likewise, 1/4 represents 1 divided by 4, which would result in a quantity equivalent to 1 part out of 4 parts. In other words, a quarter of a whole. Now I'm at the top of 127. You can't just add numerators and denominators together, as that would be like adding apples and oranges together. Instead, you have to look at the fractions as divisions of the same quantity or the same parts of a whole. Once you do, you can simply add the numerators together to find the sum or subtract the numerators to find the difference. Now here's some don'ts. Okay, these are incorrect. These first 3. 1/2 plus 1/4 would be 2/6. Look at that. So 1/2 means half of a whole, plus 1/4 means 1 of a group of 4. And you can't just add those together because look at 2/6. If you added 1 and 1 to get 2 and 2 and 4 to get 6, look what 2/6 is. Does that equal 1/2 and 1/4? It does not. What about 1/2 and 1/4 at the bottom? That's subtraction. You can't do that. Actually, no, that's addition. Why do they do that twice? Okay. What about 1/2 and 1/4? Oh, I see what they're doing. They're doing it. They're doing it different. But anyway, all those 3 are incorrect. They're showing you that the pieces don't add up. Now the last one's correct. What they did was they changed 1/2 to be 2/4, and then they added 1/4, and they got 3/4. See what I'm saying? So where it says that you have to change the fractions to be the same quantity or same parts of the same whole, You can't add a whole of 2 and a whole of 4. You have to change the 2 to 4 to match so that they're the same. All in all, it boils down to where they have to have the same denominator. That's what it boils down to. Subtracting fractions follows the same principle as adding them. To subtract 1/2 yard from 2/3 yard, you have to first express them as divisions of the same parts of the whole, of the same whole. Then we can subtract the numerators to find the answer. So the original problem is 2/3 minus 1/2. You can't do that because you can't take a part of 3 and a part of half and subtract those. You have to rewrite those to get the same denominator. So here they changed 2/3 to 4/6, and they changed 1/2 to 3/6. They get the same denominator. Then they can just subtract the numerator. But notice, these are equivalent fractions. They changed them. That's why we started out with equivalent fractions, so you can know how to change them to equivalent fractions. So 2/3 is changed to 4/6. It's the same amount, the exact same amount. 1/2 and 3/6, same amount. They just use different numbers. And that equals 1/6 after they do the subtraction. Okay, turn the page. At the top, it tells you basically the rule. In short, to add or subtract fractions, we rename the fractions by multiplying or dividing by a fraction worth 1 to get all our denominators the same. Then you add or subtract the numerators. Now, how do you know which denominator to use when adding or subtracting? Any number that all the denominators we're trying to add are a factor of will work. Now, when in doubt, just multiply the denominators you're trying to add together and use that number. Here's an example. So add 7/8 pound, 4/5 pound, and 1/2 pound. Notice all three of those have 3 different denominators. We need to find a number that contains 8, 5, and 2. Now we know 8 times 5 is 40. And 40 is also divisible by 2 because 2 times 20. So we're going to use 40 as the new denominator because all 3. We could have also used 80 because 8 times 5 times 2 is 80. It doesn't matter which denominator you use so long as all the fractions can be rewritten as an equivalent fraction of it. So now we just have to rewrite each fraction as a fraction of 40. Let's start with 7/8. How do we know what to multiply by? To figure it out, stop and think through what we're trying to find. We want to find the factor that multiplied by 8, our current denominator, gets us 40, our desired denominator. We can mentally divide 40 by 8, which gives us 5. If we multiply 7/8 by 5/5, remember a fraction by 1, we'll end up with 40 as our denominator. So 7/8 times 5/5 gives us 35/40. So we have 40 is our denominator. Remember, we're trying to get all 3 of those to have 40 on the bottom. You do the same thing with the others. To go from 4/5 to get 40 on the bottom, just multiply 8 over 8 because the only way to get from 5 to 40 is multiplying by 8. Well, whatever you do on the bottom, you have to do on the top because remember, it has to be 1. And then 1/2 would be times 20 over 20. Okay, now you got all the denominators are 40, so now you can just add across. So it's 35 plus 32 plus 20 equals 87/40 pounds. Now then you have to simplify because that's an improper fraction. So when you simplify and you divide, you say 40 goes into 87 2 whole times with 7/40 left over. And that's your simplified answer. Now, here's another thing to keep in mind. Whenever you need to add or subtract whole numbers, they're really easy to use. If you're adding whole numbers, look at the top of 129. There's 2 whole yards of fabric plus 1/4 of another. Your answer is 2 1/4. You just add them together. Now what about when you subtract? Look at the example there down just a little ways on page 129. If you have 2 minus 2/3, okay, rewrite the whole number as a fraction with the same denominator because we need 3 on the bottom, so just rewrite it as, why'd they put 6/3? 2 minus 2/3. 6/3. Oh, because I'll have to show you on the screen. Because the 2 A whole number, remember that's 2 over 1. Because remember, that's how you write a whole number as a fraction. But we need 3 on the bottom. So 1 times 3 is 3. And so you'd have to do 2 times 3 on the top, which gives you 6/3. That's where they got 6/3. And then they can subtract. I'm going to show you how to do it on the screen. It's hard to say it unless you see it. So anyway, the keeping perspective, you can read that if you want to. I'm not going to read it to you. But I'm going to show you how to do it. And then I'm going to kind of work you through your worksheet. And then I'm going to let you have it. Okay? Okay. So here's what we're going to do. I'm going to show you how they did. Well, let me just show you kind of how to do this. Okay, so we're going to take, I'm just going to give you an example. I'm just taking this out of my head. Okay, we're going to add, oh my gracious, come on here. Okay, so 1, we're going to say 1/3 plus 2/4 plus how about 3/6. Okay, remember you can't just add those across because those are different parts of a whole. All these need to be the same. They need to be the same parts, which means we need to change each one of these to an equivalent fraction. So the way we figure out how to do that is we look at these bottom numbers. Let's think what all these, the number they're all divisible by. Let's think of, there's a lot of numbers we could use. We could do 12. They all can make 12. 3 times 4, 4 times 3, and 6 times 2. So let's just use that. So 1/3. We're going to convert that to something with 12 on the bottom. Now, how do we get this? That would be 4, right? So whatever you do here, you got to do here, because remember it has to be the same fraction, 4/4. So 1 times 4 is 4. Okay. 2/4. And remember, we got to make 12 because we got to have the same denominators to add them up. So how do we do this? This would be times 3, right? So we got to do it up here. So that'd be 6. Okay, now 3/6. Remember, we got to have 12 because we got to have the same. This is times 2. So this is times 2. That would be 6. Looky there. We have all of our denominators the same now. Now, these numbers are the same. They're equivalent to these. So whatever we get is going to be a good answer. So let's add this up. So 4 and, let's see, 6 and 6 is 12, plus 4 be 16/12. But, oh, sorry, I ran out of room down here on the bottom. This is 16/12. But 16/12 is improper, isn't it? So that's really not our final answer. Let me give you a second and see if you can figure out what it would be. Know what you got? Okay, but this can be simplified. Okay. Now the 1 can stay the same. We don't have to change it. We just need to make this in smaller terms. What number can both of these be divided down by? 4. 4 divided by 4 is 1. 12 divided by 4 is 3. That, my friend, is our final answer. So 1/3 plus 2/4 plus 3/6 would give you 1 1/3. Does all that make sense? Now I want to show you one more thing. Again, this should be something you've learned before. Oh my goodness. Oh my gracious goodness. Come on here. Woo. Alright, this is on page 129 where they took 2, oh my goodness, 2 minus 2/3. Okay, now remember this is actually 2 over 1. when you write it correctly. So this is actually what you have. But you cannot subtract because they don't have the common denominators. So basically, we're going to do the same thing here. Okay, 2 over 1. I like to do my numbers vertically. It helps me see things. Some people do them horizontally this way, but I got to keep mine this way. Now, get my fraction bar ready. Now, 3 and 1. What is a common denominator? That's easy. The only thing you could have is 3, right? That's the only thing you could get that because you're using 1 here. Okay, so this would be the same, right? Because this would be times 1 times 1. So this fraction stays the same. 1 times what is 3? 3. So this would be times 3, which would be 6. Remember, this was a subtraction problem.
Mom, can I have some tea?
Not right yet. In a few minutes.
What is that for?
Okay. I'm recording a lesson for the girls, okay?
Who?
For Libby and Carmen and Calista.
Oh.
Yeah, shut the door. All right, once we have our common denominators, we just subtract. 6 times 2 is 4. And of course, we just bring our denominator down. Woo! Not what we need. 3 goes into 4 one whole time with 1/3 left over. And that is your final answer to this. Okay, easy enough? All right, let's look at worksheet 5.6 then. All right, 5.6. And now this is front and back, but I think the back is just kind of some, well, it is, it's fractions. Number 6 is just, well, that's fractions too. All right, you can use your calculator anytime you see the calculator symbol. So on number 1, A, B, C, and D, add your fractions. Remember, you got to get common denominators where they have the same denominator. Okay, so I'm going to let you work through that. I'm not grading this page. I want to make sure that you completely understand fractions before I grade you on it. And then there's just a problem there at the bottom. I'm going to let you work on that one. And these problems on the back, again, I'm not grading it. So just try your best to hand at it. If you need help and you just can't do it, that's okay. But otherwise, think through it. Go back through the book. Watch the video again if you need to, or listen to it. You don't have to watch it. And see what you can do on that. I will not grade this page. I want to see it. I want to know if you have trouble with it. If you did it fine, that's great. Then you can just send me a thumbs up or something if you want to. Okay? That is all your math lessons for the week.